So we are discussing vertical circular motion. I am classifying into three categories: critical, greater than critical, and less than critical. Less than critical. So here, now critical means, first of all, what do you mean by critical? You have to understand. Critical means these are minimum values to have a vertical circular motion. Minimum values to have vertical circle. Minimum values to have vertical circle is called vertical circle. Minimum values to have vertical circular motion or comes under critical. Less than those values we can't have. That means these are minimum values. Least possible values to have vertical circle. Less than those values we can't have vertical circle. Those are critical. Greater than critical. If you the values are greater than critical, then also we can have vertical circle, but less than critical we don't have vertical circle. So we classify in two categories. What are the values? I told minimum values to have vertical circle. What are the values means? The values means here I'm taking about tension and velocities. Minimum values of tension required at that instance and velocities at that instance for having the motion, vertical motion is called critical. So let us check it out. First, let us start our journey with critical condition. Critical condition. So here, when we are observing critical condition, first, so a body from bottom, it is a stone, suppose I am taking here. It is hanging from a string and velocity at bottom is given here. So bottom, I am projecting the body with some velocity here, VBOT, bottom, so that the body is traveling along the circle and reach to the maximum point here, maximum height. So maximum height at their velocity is, this is because maximum height means what we can say now here stone is here. We can observe clearly here, that is a stone is there. We are taking the stone. This is our stone here, tied to the string, tied to the string. This is the string we have taken and stone is here. The velocity which is projected bottom is V bot. So that here it is going to the, like that it is making the turns here and it went to this particular point. And your velocity at this highest point is taken as top. Velocity at top here. One more thing, the tension always acts towards the point of suspension. We know that tension at bottom is TPOT. When the object is at highest point, the tension in the string is a T top. So here what happened? We are connecting a stone to a string here and it is drilled in vertical circle. It's drilled in vertical circle. So it is going like that, and this is the bottom position, this is the top position, and tension, this is the center point O from where the string is suspended. So always tension will act towards the point of suspension. So tension will act towards the point of suspension here. From that information I can write. So T at bottom, this is tension at bottom. T at top, tension top also act towards the point of suspension. Velocity at bottom, velocity at top. First you have to find these values. For finding these values, I am taking what are the other forces acting on the body here. So let me take the body mass as M. Weight will act downward. The weight is mg. And other force acting downward is nothing but centrifugal force. What is the centrifugal force act here? The radius, let us take the radius, that is the length of the string. Radius is nothing but length of the string, L. So always the force acting outside is called centrifugal force. So the centrifugal force here is mv square by L. You know the centrifugal force formula, mv square by R used to write. R is radius. But here radius, what we are taking it as length. So the centrifugal force, what I have written here is mv square by R. I have written as mv square by L. Always acts radially outward. Now, what are the other forces acting here? weight always acts downward. Weight is acting downward here. And centrifugal force again upward. Here outward, that is outward, mv square by L. mv square by L, because L is length of the string. You know that always weight acts downward. Centrifugal force outward. Centrifugal force always acts outward. So these two things are clear. And tension always towards point of suspension. So the positions what I have taken. This is one position, is the top position here. Everywhere mass is m, only same object is revealed. So mass is m. So the forces what are acting here are three forces: tension, weight, and centrifugal force. Let us see only the bottom position. First bottom position. We'll discuss about only at bottom situation. What is that? At bottom situation, if you observe here, bottom situation, tension at bottom is acting towards the point of suspension, mg is acting downward, and the speed here is vbot. So centrifugal force I have to write mv bottom square by L. In previous diagram also you can check once here. So here mv I have to write mv bottom square. So here at the top, I have to write mv top square, because top and bottom speed is different. Speed at bottom and top are different. So I have to mention like that. Now let us check here. So this is the bottom position. Bottom position. This is the point of suspension. This is the O. And mg downward. mv bottom square by L downward. So from that information, I understood that tension at bottom is equal to mg plus mv bottom square by L. mv bottom square by L. This is the formula for tension at bottom. So now we got tension at bottom formula. And what is the total energy at bottom? At bottom position, it has no potential energy, only kinetic energy. Total energy at bottom is potential energy at bottom plus kinetic energy at bottom. Bottom position, there is no height. There is no height means no potential energy. So I can write total energy at bottom position is only kinetic energy. Kinetic energy at bottom means what is the speed at bottom here? Speed at bottom is V bot. So I can write here total energy at bottom is equal to I can write it as of mv bottom square This is the formula. So remember these two formulas here. One about total energy at bottom. Other one tension at bottom. These 2 points to be noted. If you remember these 2 points, we'll use these things later. So I hope you are clear with the bottom idea. Now let us take the next situation at the top. What will happen? So if you observe the diagram at the top, the weight of the body here is acting downward. Anyhow, tension always acts towards the point of suspension in the string, and this point is O, center point. And another force acting outward, because top velocity is V top. We have written here top velocity. So mv speed is v top. We can write mv top square by radius. Radius is nothing but length. Length of the string is L. So like that I can write the formula for forces. Here we are observing three forces: tension, weight, and centrifugal force. So first of all, using that one, I can write tension plus weight is equal to mv bottom square by mv bot. Oh, sorry, it is the top weight. So mv top square by length of the string is L. What you wrote, sir, here? Sum of upward forces equal to sum of downward forces. Downward forces tension and mg. Upward force mv top square by L. So I have written this one. But remember, this is tension at the top. In during critical condition, the only assumption we are making, at a critical condition, tension at top is negligible. So negligible means its value I can take it as 0. Negligible means tension at top nearly equal to 0. Now, tension at top, that is the assumption we made in critical conditions. Critical conditions, tension of the object, tension in the string when the object is at top position is nearly equal to 0. So from that information, now above equation can be written as tension at top is 0 means mg plus mg, sorry, here mg is equal to mv top square by L, mv top square by L, because tension is 0. From this expression, I can cancel m and I can write v top square is equal to gl means speed at top is equal to root gl. Speed at top equal to root gl. This is our first step. So TF velocity at top is equal to what we got? Root GL. So velocity at top we got. Now the question is, what is the total energy at the top? Total energy at the top. That is the question they're asking. Observe carefully. Now, total energy means, so this is bottom, this is the bottom, and this is the position is top. So if we observe bottom on top, from here to L length is L, and from here to L length is L. So what will happen at top here at this position? The speed is v top. So what is the height from the ground? Height from the ground is nothing but, here I can simply write h is equal to 2L. Diameter. Diameter is the height from bottom to top. So h I can write it as 2L. What is the height from ground? 2L I can write. So height from ground is 2L. So what is the total energy? Total energy at top is nothing but, we have the formula, potential energy at top plus kinetic energy at top. Kinetic energy at top. Potential energy at top means potential energy formula, weight into height from ground. Weight is mg. Height from ground, it is h. H value is 2L. Height from ground is 2L. Kinetic energy at top, I can write of mv top square. Of mv top square. So already we know V top value. Just now we derived V top value as root GL. Substituting that one, V top value, just now we got that expression. Total energy at the top is equal to mg into 2L plus half into m into root GL whole square. Because V top square, V top is root GL. V top square means we'll get root GL whole square. So we can write here as GL. So 2mgl plus half mgl, what should I write? Tension at the top, total energy at the top is equal to, I can write 5 by 2 mgl. Total energy at top is equal to 5 by 2 mgl. This is the formula for total energy at top. Total energy at the top. Now, let us check once. Here we got total energy at the top. Actually, we told that what is the total energy at bottom? We derive total energy at bottom as half mv bottom square. Half mv bottom square is the total energy at bottom. Total energy at bottom is half mv bottom square is the total energy at bottom we got. That is half mv bottom square. So total energy at any point will remain constant from law of conservation of energy. So we know that point. So if you take that issue here, we have total energy at top is 5 by 2 mgl, and we got total energy at bottom also from law of conservation of energy. From law of conservation of energy, what we can write here? Total energy at any point is same. That is total energy at bottom is equal to total energy at top. Total energy at bottom of mv bottom square, of mv bottom square. Total energy at top, we got 5 by 2 mgl, 5 by 2 mgl. So I can cancel this m and m. 2 and 2 I can cancel. So I can write now v bottom. What is v bottom? Root 5 gl. Velocity at bottom is root over 5 into G into L. This is velocity at bottom. So we got the velocity at bottom also root 5 GL. We found velocity at top, tension at top, and velocity at bottom. Now the question is, what is tension at bottom? Tension at bottom. Already we got some expression for tension at bottom. If you go back and check what is tension at bottom means, here we observe that sum of upward forces, that is tension at bottom is equal to sum of downward forces. So tension at bottom is equal to mg plus mv bottom square by L. mg plus mv bottom square by L. So here, what is v bottom square by L? This is the formula we have. I am taking this tension at bottom as mg plus mv bottom square by L. So now, what is happening? That we got tension at bottom is equal to mg plus mv bottom square by L. Just now we derived the v bottom value. What is the v bottom value? We told it is nothing but root 5 GL. Where did you got this one, sir? Here only, beta. You can check here. From the law of conservation of energy, I derived velocity of bottom, that is root 5 GL. Root 5 GL. So now I am substituting here in the expression for tension at bottom. I can write mg plus m into root 5 GL whole square by L. So what is tension at bottom? We will get here mg plus 5 mg. GL will be cancelled. That is, sorry, LL will be cancelled, and we'll get 5 mg. So 5 mg plus mg, 6 mg. So tension at bottom value we got 6 mg. Tension at bottom we got 6 mg. I think you understood the different values here. When the body is moving in a vertical circle, what is the velocity? This is under critical conditions. We are discussing per critical. I told that velocity at bottom, just now I derived it as velocity at bottom as root 5 GL, where L is left. Tension at bottom, what is tension at bottom here? The mass is here M. Tension at bottom is equal to, just now I derived it as 6 mg. This is the point from where we are suspending the block of mass M here. So here, now what happened again at the top? What we are getting here, you check it out. Here, if you observe, this is at the top position. In the top position, what we got here is velocity at top. Velocity at top is equal to, I can write root GL. I got root GL. I assumed actually tension at the top is equal to, tension at top is nearly equal to 0 in the critical situations. So these are the values what we got. Let us check the previous thing, previous slide, what we have beta here. So we have got here law of conservation of energy here. Law of conservation of energy. From after that, we got the tension bottom expression as 6 mg by substituting in the place of V bottom. In the V bottom, root 5 GL we substituted and we got 6 mg at bottom. So now, these are the conclusions what we made for velocity at bottom, velocity at top, tension bottom, tension top. And one more important conclusion, that total energy at any point, TE means total energy at any point, is 5 by 2 mgl. Either it is a bottom or top, anywhere. From law of conservation of energy, we can say total energy is 5 by 2 mgl. That may be at top or bottom or horizontal or at any position. This is a situation when we are discussing about critical conditions. So in critical condition, suppose they are asking us what is the velocity at any instant. I don't want at top or bottom. I want at any instant. Somebody asked me, sir, okay, sir, you have given the values only at the bottom and top. I want at horizontal. What is the velocity value, tension value? Like that they're asking. For that, we'll discuss for at any instant. 30 degree, I can give with theta can be 30 degree, theta can be 60 degree at any instant. Let us take velocity at any instant. Here is v theta. Tension at that instant is t theta. So this is the situation what is given. Now velocity at bottom value we know. Velocity at bottom is, what is the velocity at bottom is? I can write it as root 5 GL. I know that value. And tension at bottom also I know. Tension at bottom is already we derived, that is 6 mg. We got that expression. And total energy at any point also I know. What is total energy at any point? Total energy at any point is 5 by 2 mgl. This is total energy at any point. So now let us observe carefully here. So what is tension and angle theta, like that they are asking here. This is at any instant. This concept is related to at any instant. At any instant. That is also with respect to bottom. With respect to bottom. Now you observe. So here from this position it is raised to some height. So from this ground position it is raised to some height. Let us take this height as h. The length of the string is L and this angle is theta. This angle is theta. Carefully observe this one beta. So here this length is L, length of the suppose like a pendulum thing. Bob is there like that you take. So length is L and here angle is theta. So now what happened? It is going from this position to this position, rise a height h. So that what I can do now? I am drawing one perpendicular here. I am drawing one perpendicular. So this is length is L. This length from here to here is L. And from here to here H. Then this part and this part, how much it will be there means. Easily you can identify that as L minus H. L minus H from here to here. Because observe carefully this one. This is now right angle triangle. Right angle triangle. In that right angle triangle, I can write cos theta. What is cos theta? In right angle triangle cos theta, adjacent by hypotenuse. Adjacent by hypotenuse. This is right angle triangle. Adjacent is L minus H. Hypotenuse is L. L minus H by L. So from here, if you just cross multiply, you will get H is equal to L into 1 minus cos theta. Remember this formula beta. H is equal to L into 1 minus cos theta I got. Sir, why you have taken this H as L into 1 minus cos theta? Sir, what is the purpose of that one? I will explain. I am taking the first page here beta. Now observe here, from this position, it is rising to some position, height is H I told. So weight will act in which direction? Downward direction. Weight will act in downward direction. So here is making an angle theta here. It's making an angle theta here. You observe some points here. So here, what I can write here is this angle is theta. This angle is theta. So the tension will act towards point of suspension. Tension always acts towards point of suspension. Tension will act towards point of suspension. So here if you observe, this resolving into components, I can write mg cos theta here. What should I write here beta? Tension I am taking here means what should I write here? This component in this direction is mg cos theta in this direction. And in this direction, mg sin theta, fine. And here velocity is also there. Actually, velocity is also there at this instant. So velocity is v theta means at that instant it also has centrifugal force. mv theta square by L. So here you have to observe some points here. So I can notice from the diagram tension theta is equal to mg cos theta plus mv theta square by L. This is the formula I got, mv theta square by L. So because here observe carefully here, tension theta is towards point of suspension. Mg cos theta and mv theta square by L are in this opposite direction. So tension at any point is mg cos theta plus mv theta square by L. Okay, just keep it aside that formula now. Now you concentrate. Here it is raised to a height h we told. From here to here it rises height h we told. So here the velocity is v theta and is raised to a height h. So what is total energy at theta? Total energy at theta means potential energy at theta plus kinetic energy at theta. Okay, fine. So what is the potential energy at theta means? I can write it as mgh. Potential energy at theta means I can write mgh. And kinetic energy I can write it as half mv theta square. Half mv theta square. So here you observe, already I told you that h can be taken as L into 1 minus cos theta. H can be taken as L into 1 minus cos theta. This is the formula already I have given in my last page. You can check. H is equal to L into 1 minus cos theta. This is the formula we discussed. H equal to L into 1 minus cos theta. Now, so here I can substitute now. That is the formula for total energy at theta. I can write now. Total energy at theta is mgh. H means L into mg L into 1 minus cos theta, 1 minus cos theta plus of mv theta square, of mv theta square. This is total energy at theta. This is total energy at theta. My request for you people is remember these 2 points. That is, one is the tension at theta, other one is total energy at theta. These 2 points to be noted. So let us first target total energy at theta. Why you are targeting total energy at theta, sir? Because law of conservation of energy. What does law of conservation of energy says? That total energy at any point is constant. Total energy at theta is equal to total energy at any point. So total energy at bottom or anything you can take. Everywhere it's constant. Total energy at bottom also 5 by 2 mgl. Total energy at theta, now what I got? mg into L into 1 minus cos theta, 1 minus cos theta plus of m v theta square, of m v theta square. From here, everywhere I can cancel m. I can cancel the term m. Here m, here m, here m, I can cancel. And multiply everywhere with 2. Multiply everywhere with 2 also. So I can write 2gl plus 2 2 will be cancelled here. V theta square. Here also 2 2 will be cancelled. And I can write 5gl. I want now. Here what we got? We wrote wrong here. Just observe carefully here. 2gl into here 1 minus cos theta is there. We forgot that. 1 minus cos theta plus v theta square multiplied everywhere 2. Multiplied everywhere 2. I can write like this 5gl. So now I want v theta value. So v theta square, v theta is equal to, I can write now, square root of 5gl minus 2gl into 1 minus cos theta. So now let us expand that to 1. So I can write v theta is equal to. Carefully observe 5gl, 5gl minus 2gl minus of minus plus 2gl cos theta, 2gl cos theta. So from this last line, if you observe this last line, now I can write it as 5gl minus 2gl means 3gl. 5gl minus 2gl, it is 3gl. And this is 2gl cos theta. From that expression, I can write v theta is equal to root over 3gl plus 2gl cos theta. So v theta value I can write as gl into 3 plus 2 cos theta. V theta is equal to root over gl into 3 plus 3 cos theta. This is velocity at any instant formula. Velocity at any instant formula is v theta. So actually we derived the velocity at any instant. Okay, velocity at any instant. Fine. That is a v theta value we got. Our target is actually one more target is t at theta. So t at theta, tension at an angle theta, tension at an angle theta means mg cos theta plus mv theta square by L. mg cos theta plus mv theta square by L. This is tension at any point. Already we got this formula. And now we know the value of v theta. Now we know the value of v theta. If you know v theta value, if you substitute here, You will get the value of tension at any point. Let us check it out, that one. Tension at any point. Our target is tension at any point. Now observe carefully, step by step. Tension at any point, just now we have written it as mg cos theta plus mv theta square by L. mv theta square by L. And as v theta value we can observe above itself. T theta is equal to mg cos theta plus m by L v theta square. V theta square means I can write GL into 3 plus 2 cos theta. GL into 3 plus 2 cos theta. Now observe carefully here. L can be cancelled. L can be cancelled. So now what is left here? We will write that expression now. T at theta is equal to mg cos theta is there here. Here if we expand that one, 3mg is there. And again 2mg cos theta. So here, carefully watch here, mg cos theta, 2mg cos theta. mg cos theta plus 2mg cos theta can be written as 3mg cos theta. So, let me take the first page here. And now we have to observe the situation that we have to take that T at theta is equal to mg plus 2m, that is 3mg plus 3mg cos theta. We got from our previous expression from here 3mg. If I take common, I can write 1 plus cos theta. This is the expression what we got for tension at any point. T theta is 3mg into 1 plus cos theta. So my final conclusions, velocity at any point and tension at any point means, what are my conclusions beta here? Tension at any point and velocity and T theta we got. Now let us observe V theta and T theta formula. T theta is 3mg into 1 plus cos theta. And velocity at that point is root over GL into 3 plus 2 cos theta. I hope it is clear. Velocity at any point, tension at any point. If we substitute theta equal to 0, bottom, theta is equal to 0, we'll get bottom. Theta equal to 90, horizontal. Theta is equal to 90, we'll get horizontal. Theta equal to 180, you will get top position. Like that you can find the velocity at any instant and tension at any instant. I hope this topic is clear, beta. We'll continue this topic again in next class. Thank you very much for attending.